Hi there. So in preparation for your test this coming Wednesday, we have a series of practice problems that we're going to work through. The first 6 all involve just taking a derivative. And so number 1 here, we're looking to take the derivative of the inverse function of f at a. And then our function of f is x squared minus x cubed minus 1, and a is negative 5. Okay, so our formula is going to be 1 over the first derivative of f at the inverse of f of a, or at a. Okay, and so then we're going to go ahead and plug in our negative 5 into our a. And the first question we have to ask ourselves, well, what then is the inverse at a, negative 5? And so that means I'm going to take that negative 5 and I'm going to put it into f of x. We're going to be at negative 5 equals x squared minus x cubed minus 1. And to be able to put it in my calculator and calc the 0, it does have to equal 0. So I'm going to go ahead and add 5 to both sides. We have 0 equals x squared minus x cubed plus 4. And if you take that and plug that into your calculator, stick it into the y equals this x squared minus x cubed plus 4, and let it calc the 0 for you, the 0 is going to occur at x equals 2. And so then we're going to go ahead and take this 2 and we're going to stick it in for f inverse of negative 5. So we're asking next, what is the first derivative of f at 2? Okay, well, f prime of x is equal to 2x minus 3x squared, and derivative of negative 1 is 0. And so then the first derivative at 2, we take that 2 and we plug it in. 2 times 2 is 4, minus 3 times 2 squared, which is 12, so 4 minus 12 is negative 8, and so our answer is negative 1/8. Okay, number 2, we're looking at a function a to the u, and the derivative of a to the u is a to the u times u prime. So derivative of 5 is 0, derivative of negative 2x is negative 2, derivative of x squared is 2x, times the natural log of a, and in this case a is that 2. And we can technically do a couple of things here to help with the simplification. We could factor the 2 out, for example. 5 minus 2x plus x squared times 2 times negative 1 plus x times natural log of 2. And then if you were looking at a multiple choice, a couple of other things you might look for, you could see if this 2, because now it's being multiplied to the natural log, this could potentially come up as an exponent. These have the same base, so theoretically they might add those exponents, so you might see 6, right, because this exponent is 1. 6 minus 2x plus x squared, right? Multiple choice, you'll be looking for what else might have happened if you don't see one of these 2 answers there. Okay, number 3, we are asked to find the derivative of natural log of 5x squared minus x plus 4. Derivative of natural log is u prime over u. So we're going to go ahead and take the derivative of our function, which is 10x minus 1, over our function itself. Next, we're on to number 4. Number 4 is the derivative of our cotangent. And derivative of our cotangent is the same as the derivative of our tangent, just with the negative. So we're going to go ahead and do negative, and then it's going to be u prime over 1 plus u squared. So u prime in this particular case is 1/3 derivative of x over 3 over 1 plus u squared, which is x squared over 9. And then right here we have a couple of extra denominators, complex fractions, so we're going to get rid of that by multiplying each of these 3 terms by the greatest common denominator, which in this particular problem is that 9. And so we're going to go ahead and go times 9, times 9, times 9. And so we're going to get negative 3 over 9 plus x squared. Okay. Number 5, we have log base 3 of x cubed plus x minus 1. Derivative of log base a is u prime It's derivative of our function, which in this case is 3x squared plus 1, over our u, which is x cubed plus x minus 1, times the natural log of a, which in this case is 3, right, our base there. And then last but not least, we have number 6, derivative of e to the u. And derivative of e to the u is e to the u times u prime. And in this case, the derivative of 3 cosine 4x is negative 3 sine 4x, and then chain rule, times the derivative of the guts. And we could rewrite that. The negative 3 times the 4 is negative 12 sine of 4x e to the 3 cosine of 4x. Okay, so those are all your derivative rules, and they correspond to the upper half of your blue formula sheet. Okay, so next up we have our logarithmic differentiation problems, number 7 and 8. For logarithmic differentiation, we start with taking the natural log of both sides. So we have natural log of y equals natural log of x squared, x minus 3 quantity squared, over square root 4 minus x. And then we are going to expand that natural log, right, the right side of that equation, using our natural log properties. Okay, so the x squared, I'm going to bring down that exponent, so we're at 2 natural log of x. And it's being multiplied, so we're going to add, bring down that exponent to natural log of x minus 3, and then being divided, so we subtract and bring down that exponent, 1/2 natural log of 4 minus x. Okay, step 3 is that we are going to take the derivative of each of those terms. Okay, so we have 1 over y dy dx equals 2 over x plus 2 over x minus 3 minus, and then u prime in this case, derivative of 4 minus x is negative 1, so that minus and negative are going to end up canceling, and then 2, 4 minus x. Okay, so minus a negative. And then our last step is to multiply both sides by that y. And then we're going to take our x's, because we're finding it in terms of x, we're going to take our x's and plug them back in. And so we have dy dx equals 2 over x plus 2 over x minus 3 plus 1 over, and I'm going to go ahead and distribute that 2 in. We're at 8 minus 2x. And then our y is x squared, x minus 3 quantity squared, over square root 4 minus x. Okay, so I'm going to go ahead and pull over a piece of scratch paper here for the combination. If we were to combine those 3 terms, if that was required within the problem, you would then look to see, well, what would be the common denominator? And each of these have a unique denominator, which means for each term we're going to multiply top and bottom by the denominator of the other 2, right? So this 2 over x is going to be multiplied by x minus 3, 8 minus 2x. Okay, so I'm just going to rewrite this problem. 2 over x plus 2 over x minus 3 plus 1 over 8 minus 2x times x squared, x minus 3 quantity squared, over square root 4 minus x. Okay. So let's go ahead and do that, multiplying top and bottom by those 2 extra terms. So this first term is going to become 2 times the x minus 3 times the 8 minus 2x. Our second term is going to be multiplied by the x and the 8 minus 2x. And our last term is going to be multiplied by the x and the x minus 3. So now we have that common denominator of x, 8 minus 2x, and x minus 3. And all of that, of course, is still being multiplied by our y here. And I'm running a little bit out of room, but it's this function. This x squared, x minus 3 quantity squared over 4 minus x. Okay, so we're going to go ahead and distribute and combine like terms. So we have our, well, 8 times x is 8x, times 2 is 16x. X times negative 2x is negative 2x squared, times 2 is negative 4x squared. Negative 3 times 8 is negative 24, times 2 is negative 48. Negative 3 times negative 2 is positive 6x, times 2 is positive 12x. Right? And then we have plus, distribute the 2x, 16x minus 4x squared, and distribute the x squared minus 3x. And still all times that y. So then combining like terms, we have our negative 4x squared, negative 8x squared, negative 7x squared. We have 16x, 28x, 38, 44x, and then 41x. And then minus 48. Over x, 8 minus 2x, x minus 3. Still all times our y. And this then is going to allow us to be able to do a little bit of simplification. The x is going to cancel with the x squared. This x minus 3 is going to cancel out an x minus 3, and we're going to be left with two possible answers. One might be negative 7x squared plus 41x minus 48 times x and that x minus 3 that are left after the simplification, all over either 8 minus 2x root 4 minus x, or remember we had originally distributed the 2 in, right? This was 2 times 4 minus x. And so right here we could potentially combine those as well, right? We have 1 4 minus x and we have a 1/2 4 minus x, and that would make 2 times 4 minus x to the 3 halves, 1 and 1/2 together. So that would be the other thing you might look for. Okay, let's take a look at number 8 then. We have, again, take the natural log of both sides. Natural log of y equals natural log of x to the 5x squared. Expand it. Natural log of y equals, bring down that exponent, 5x squared, natural log of x. Take the derivative, 1 over y dy dx equals 1 d2 plus 2 d1. I'm going to go ahead and rewrite that, simplify it up a little bit, because here the x squared and the x are going to cancel, so we're left with just 5x. And I'm going to bring that 10x to the front to make sure there's no confusion. That 10x is not part of our natural log, so we're going to stick it in front of our natural log. So then our last step is to go ahead and times both sides by y. So we have dy dx equals, I'm going to factor out a 5x here, so we have 5x times 1 plus 2 natural log of x times my y was x to the 5x squared. And the only other thing you might look for with this particular one is, because we have an x to the 5x squared here and an x over here, right, they have the same base, those might get combined by adding the exponents. This one has an exponent of 1, this one has an exponent of 5x squared, and so you might look for something like 5x to the 5x squared plus 1 times 1 plus 2 natural log of x, or something along those lines. Okay, so next we are on to our integrals. Okay, so number 9, we are looking at the integral of x times 3 to the 4x squared dx. Okay, and I notice here I have a number as my base, which means it's probably going to be number 4 on my integral rules, a to the u. Okay, if that's the case, then that has to be my u, that 4x squared. And if 4x squared is u, du would be 8x dx, and sure enough I see I have x dx, so the only thing I have to do is get rid of that 8 by dividing it over. Okay, so now I can do my u du substitution. 1/8 du goes in for x dx, so we're at 1/8 du. And then this 4x squared becomes my u. And now I'm set to apply my rule number 4, integral of a to the u. And the integral of a to the u is a to the u divided by the natural log of a plus c. Okay, so then we'll go ahead and combine these fractions and substitute back in for my u. So we're at 3 to the 4x squared over 8 natural log of 3. And the only other thing you might look for in this particular case is in some cases you might see this number being brought up as the exponent, right? Natural log to the natural log of 3 to the 8th, something like that. Okay, number 10, we have integral of 1 over square root 4 minus 9x squared dx. Looking at my integration rules, this looks the most to me currently like arc sine. Okay, arc sine is 1 over the square root of a squared minus u squared. So I'm going to see, can I rewrite it in that form? Right, 1 over my a squared, square root of my a squared, which would be 2, minus my u squared, which in this case would be 3x. However, because there's something in there with that x, I'm going to have to do a u to u substitution here, right? So my u is going to be 3x, and my du is going to be 3dx, and so I'll go ahead and divide that 3 over 1/3 du equals dx. So now I can do my u to u substitution. 1/3 du goes in for dx, so we're at 1/3 du. My a is 2 and u. Okay, and so now we can apply our rule. We have 1/3 arc sine of u, which in this case is 3x, over a, which is 2, plus c. Okay. On to the back, we have number 11. We have integral of 4x over x squared plus 1 dx. And so if I try to make my entire denominator the u, the hope in doing so is that we'd be able to apply our natural log integral. So u is my x squared plus 1, du is 2x dx. The only difference between this 2x dx and this 4x dx is timesing both sides by a scalar of 2. So now I can do my u to u substitution. 2 du goes in for the 4x dx, and the x squared plus 1 becomes u, and now it's my natural log. So I have 2 natural log absolute value of x squared plus 1 plus c. Okay, number 12, we're looking at integral of 2x over 9 plus x to the 4th dx. And so you might try, like we did before, making the whole denominator our u, see if that gives us some sort of breakthrough. You might try the x to the 4th as your u specifically, as opposed to the whole 9 plus x to the 4th. I don't know, you're going to try several different things. But eventually, we're going to work our way down to our last rule, which is the arctan rule, which says the integral of 1 over a squared plus u squared. Okay, so let's go ahead and rewrite this. 2x over a squared, which is 3, plus u squared, which is x squared. because x squared squared is x to the fourth. And right there, it's our arctan, but because there's something in there with that x, we're going to have to do u du substitution. So my u is x squared. My du is 2x dx. And so I can go ahead and do a u du substitution. 2x dx becomes du. We still have our a, and now our u. And so we're good to apply our arctan rule, which says 1 over a arctan u over a plus c. Okay, number 13, you're going to try a couple of things. Try a u du substitution, try completing the square. So when we do our u du, we get u is x squared plus 6x plus 13. Du is 2x plus 6 dx, and we notice that's pretty close to what we have, 2x minus 4, 2x plus 6, right? The only difference being that last term. And then when you try your completing the square, down here we'd have x have it plus 3 squared. 3 squared is 9, but we have 13, and so we add 4. And so that's going to give us then that a squared plus u squared that allows us to apply our arctan rule. But just doing arctan, we won't have gotten rid of that numerator, 2x minus 4. And so here's our clue that we're going to have to use both of them together. We're going to have to split the fraction. So I'm going to go ahead and rewrite this. 2x, and then I don't want it to say minus 4. I'd really like it to say plus 6. So I can do my u du substitution. So I'm going to go ahead and make it that, 2x plus 6. But we have to maintain equality. It was originally minus 4, so we're going to go ahead and subtract 10 from it. That way 6 minus 10 is still negative 4. And we're over x squared plus 6x plus 13 dx. Okay, so now we can split the fraction. We have 2x plus 6 over x squared plus 6x plus 13. And that's going to be my u du piece. And then this minus 10, and this one is going to be my complete the square piece. And we already did the complete the square over here. So I'm going to go ahead and put that in. We're at 2 squared plus x plus 3 squared dx. And so now we have our two pieces. We have our u du and our arctan. So that's the last step. Natural log of x squared plus 6x plus 13. And there's no extra scalar because we didn't have to divide anything over with our u du. It was a direct u du. And then we have our arctan, which is 1 over a arctan u over a plus c. And then the last thing that I would probably look for here, although I am running a little bit out of room, would be this 10 times the 1/2 simplifying. So we're at natural log of x squared plus 6x plus 13 minus 5 arctan x plus 3 over 2 plus c. And so that there is going to be my answer. So we are on to number 14. Number 14, integral of cosecant 2x dx. And there is a rule that says integral of cosecant u. So there's my u. There's something in there with that x, so we have to do a u du substitution. And there's no extra 2, so I'm going to divide that 2 over. Okay, so rewriting this problem, scalar cosecant u du, and now I'm set to apply my rule. My rule says integral of cosecant u is negative natural log of cosecant u, which is 2x, plus cotangent u, which again is 2x, plus c. On number 15, 3x cubed plus x minus 1. Okay, so we have a singular term in the denominator, which means you can view it two different ways. One, you can think of it as splitting that denominator to each of the numerator's terms and simplifying. Or you can think of it as changing that to x to the negative 1 and then distributing it in. Personally, I always think of it as distributing to each of those terms. So 3x cubed over x is 3x squared. X over x is 1, and 1 over x is still 1 over x. And then we can take the integral of each of these pieces, add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent, and then this last piece is our natural log. Okay, number 16. Again, a case where you might try a variety of different u's, du's, but again, you're going to work your way all the way down and then see that arctan and go, well, let's just try to put it in that form. What does that look like? Well, it looks like x squared over my a squared plus my u squared. Okay, but just like before, there's something in there with that x, so we have to do a u du substitution. So u is x cubed, means du is 3x squared dx, so there's the x squared dx. So let's go ahead and divide that 3 over 1/3 du equals x squared dx. Okay, so we're looking at u du substitution. 1/3 is my scalar. X squared dx becomes du. And we're 1 over my a squared plus my u squared, which allows me to then do my arctan, which is 1 over a. In this case, a is 1, so 1 over 1 is 1. Arctan u over a, my u is x cubed, and then that u, that x cubed, over my a, which is 1, would just be x cubed plus c. Okay, on to number 17. Number 17 here, I'm going to go ahead and separate my work from number 13. It bled over a little bit. Okay, it looks like a to the u, so that would be my u then. 3x plus 1 makes my du 3 dx. There's no 3 in the original integrands. We're going to go ahead and divide that 3 over. And now we're set to do our u du substitution. So this is equal to scalar integral 2 to the u du, which is scalar a to the u over natural log of a. Go ahead and combine that. We have 2 to the u, which was 3x plus 1 over 3 natural log of 2. And again, we mentioned it before, but one more time, always be aware that that 3 that's in front of the natural log of 2 being multiplied to the natural log of 2 could be brought up as an exponent, right? 2 to the third, and 2 cubed is 8. So that might be something you need to look for within the context of your problem. And then last one of our integrals here, we have integral of x tan x squared dx. This is a u du substitution because there's something in there with that x. So my u is x squared, my du is 2x dx, and there's the x dx, x dx. So let's go ahead and divide that 2 over. So then we can do our u du substitution, scalar integral tangent u du. And the integral of tangent u is negative natural log of the absolute value of cosine my u plus c, or the other one would be the natural log secant x squared plus c. And there's my last integral. Okay, and so then last two problems, numbers 19 and 20, are find the general and or particular solutions for the differential equations. Okay, so number 19 is a particular solution because I've been given a point. Okay, so first we need to find the general solution, which means I need to get the y's on one side and the x's on the other. So I'm going to go ahead and divide this y over. So we're at 1y dy equals, and then times that dx over. So we're at 1 over x dx. So again, divide this y over to be with the dy, times this dx over to be with the x. Okay, and so then integrating, taking the integral, we have natural log of the absolute value of y equals the natural log of the absolute value of x plus c. And then we're going to go ahead and solve for y by raising everything to the e. Okay, so the e and the natural log are going to cancel each other. We have y equals, okay, this plus c, because of our exponent rules, is going to come down and become c. And then e to the natural log are going to get canceled. I'll go ahead and show that step actually as a secondary step. So e to the natural log cancel, and we get c times x. And so then because this is a particular solution, I'm going to take that point and I'm going to plug it in. So we have negative 3 equals c times 6, and solve for c, and we get c equals negative 1/2. And so then my final answer is y equals c is negative 1/2 times x. And then number 20 is just general. There's no point, so there's not going to be a particular solution. Okay, so we're going to divide this y plus 1 over, and we're going to times both sides by that dx. So we're left with 1 over y plus 1 dy equals x squared dx. And then take the integral. So we're at natural log of y plus 1 equals 1/3 x cubed plus c. Okay, we have our natural log rule here with the u du, and we have our power rule here. Add 1 to the exponent, divide by the new exponent. And so then solving for y, we're going to raise both sides to the e. E and natural log are going to cancel, and so we're at y plus 1 equals, bring down the c, e to the x cubed over 3. And then last step, subtract both sides by 1. And so our final answer is y equals c e to the x cubed over 3 minus 1. And that minus 1 is not part of the exponent. That minus 1 is attached to the entirety. Right? c e to the x cubed over 3, there's your exponent, minus 1. Okay? And those are your practice problems.